So in our physical world, there are different kind of quantities we see around, just like my height, your weight, the length of a rope, etc. So to determine these quantities, there are two types of things, which is a vector and a scalar. These are two types of quantities. Now, vector, it has magnitude, and scalar also has magnitude. The difference is that vector, it has direction. That is one difference in both of their types. So let's discuss vector today. So let's say I have a line that goes right there. So this line, let's say it's A, and to project it as a vector, we have to give an arrow sign over it. So that is a vector A. So it is determined that a vector is equal to the magnitude of A, which is without the direction, so it is given a sign like this, and a unit vector, which is a cap, it's determined by a cap. So this one here is magnitude, and this one here is a unit vector. Now let's just talk about different types of vector. So first of all, vectors can be of two main types, which is a polar vector and an axial vector. So polar vector, they are all straight. By straight, I mean that there will be a straight line determining this vector. An axial vector, it is curved. So let's say this type of vector or this type of vectors, these are all axial vectors. And mainly we'll talk about here are polar vectors. So first type of polar vector is the rectangular unit vector. So rectangular unit vector, let's say you have a graph. So let's say you have a graph. This is the y-axis, this is the x-axis, and this is the z-axis. So z-axis are there also. Okay, let me draw it again. So let's say you have a graph of x, y, and z-axis. Z also there, x is also there, also there. Okay, so this is a graph of Cartesian coordinate system. So this is the y-axis, and this is the x-axis, and this is the z-axis that is coming out of the picture. Let's assume that. So there are the x-axis, it is determined with I cap, that is the unit vector for x-axis, unit vector for y-axis is j, and unit vector for z-axis is k. So that is the system it works, rectangular unit vector. And let's suppose a vector goes right there, which is a vector, let's say, and it creates an angle with the x-axis, which is called alpha, and if it creates an angle with the y-axis, it will be called beta, and when it creates angle with the z-axis here, it is called gamma. So beta, alpha, gamma, these are all axes, the axis angles. So a law states that the sum of the squares of these cosines of these angles will be always equal to 1. So let's say cos alpha whole square plus cos beta whole square plus cos gamma whole square, these will always be equal to 1. So this is the law of Cartesian products in vector forms. So that is the rectangular unit vector. Let's move on to the next thing. So next thing on the list is position vector. Position vector. Position vector. So position vector is very easy. Let's say from any point O, a vector goes like this. Point goes to A. So OA vector is a position vector. OA is the position vector. And the distance of this vector is from there to there. It is determined by R vector. See the position, the distance from O to A is determined by R vector. R vector now, a different type of vector is position vector. Now about displacement vector. Displacement vector is very hard to get, but I'll make it easy. So let's say from any point a vector goes in two directions. Two vectors, which is R vector and another, let's say this is the R initial vector and this is the R final vector positions. So, and this is the displacement of these two vectors, which is determined by R. So delta R vector, that is the change of vector, it will be equal to the R, which is the final R minus the initial R. So this is the displacement of these two vectors. So this is the displacement vector. Now let's move on. Like vectors. Like vectors. What are like vectors? So let's say you got two vectors, vector A and let's say vector B, and the direction of these two vectors, the direction of A, so let's say A is on by unit vector A and some magnitude, let's call that C, magnitude C, and let's say unit vector B, it has some magnitude and a unit vector of B. So in this case, this A will be equal to this B unit vector. So both the unit vector will be same because their directions are the same. These are like vectors. And another type of vector is the unlike vector. So unlike you got from it, we use the suffix or a prefix that is un. So that is not like these vectors. So let's say one vector A and another vector we determine B and another vector we determine C. So A vector and B vector are like vectors, but B and C are unlike. A and C is also unlike because the direction of C is opposite of both A and B or any reference. So we will say that C vector is unlike vector of both A vector and B vector. So these are unlike vectors, the directions will not be the same. And the reciprocal vector, when we hear of reciprocal, what do you know? So let's say x, the reciprocal will be 1 by x. Not equal to, this is the reciprocal. X and reciprocal from will be 1 by x, or if the reciprocal 1 by x, we will get x. So that is the reciprocal. And what are reciprocal vectors? Reciprocal vectors are, let's say, any vector A, it has magnitude of 69, and let's say I cap unit vector. So if B, another vector B has V has 1 divided by 69, and let's say I cap, then we will say that A vector is reciprocal of B vector. So these are reciprocal vectors. Very easy vector. And now the second one is the opposite vector or negative vector. The opposite or negative vector. So opposite vector, that means if any vector goes in this direction, this direction there, the opposite vector will go in the opposite direction. Hence, let's say in a Cartesian, let's bring out a Cartesian product, Cartesian coordinate system. Let's say this is a Cartesian coordinate system of x, y, z. This is the positive x, this is the negative x, this is the positive y, this is the negative y. Let's not bring out z in here. So let's say one vector is in positive x direction, which is vector A, and another vector that goes in the negative direction of x. So it is going in the negative direction, it is going in the positive direction. So they are opposite vectors, or we can say negative vectors. Now, next type of vector, what we got here is free vector. A free vector is a type of vector which has no reference point, and this a vector is moving. This free vector is a free vector. So a is moving, but there is no reference. There is no point where it started. There is no initial point. We assume that it has been moving from, let's say, infinity. So this is a free vector. And a proper vector is a vector, let's say, if vector A is equal to a constant of magnitude c, and let's say a unit vector I, and where c will not be equal to 0, then a vector is proper vector. So we can say that in any vector, if the magnitude is not 0, it's not equal to 0, it can be anything else other than 0, it will be called a proper vector. Now let's move on to another type of vector. Next on the list is localized vector. So it's just the opposite of free vector. It is localized. That means it has an initial point. So from initial point O, vector A moves, and let's say a vector B moves. So A, B both are localized vectors because it has a initial point. So these are localized vectors. And we got here open vectors. Open vectors. Let's again bring up the Cartesian graph. So Cartesian graph. This is the Cartesian graph. Let's just deny the z-axis. Okay, let's just say z-axis. So a vector is here. Let's say a vector is here, but we move it from there to there. Let's say we moved the a vector. We move this a vector from point, let's say, C to point D. So we moved the vector A from point C to point D without changing the magnitude or the direction. So neither the magnitude nor the direction is changed, but we moved the vector A from the point C to the point D. So this type of vectors is called open vector, OPN, open vectors. Now we move on to the next type of vectors, which is equal vectors. So equal vector is easy. Equal vector is a vector whose magnitude is equal and the unit vectors are equal. That are called the equal vectors. Let's say vector A, it has C and I unit vector. Vector B also has C, I unit vector. So as both the same, A and B vectors will be called equal vectors. Now, collinear vectors or planar vectors. Let's bring up the Cartesian graph. So in vector, these graphs are very important. These Cartesian graphs are very important. So this is the y, this is the x, and this is the z. This is the inverse one, the dot dot dots. So let's say a vector here, vector A. Another vector here is vector B. Another vector here is a vector C. So only if vector A parallel to vector B, forgot to give the vector sign, parallel to vector C, these will be coplanar, or you can say collinear. So only if they are parallel to each other, the vector A is parallel to vector B to parallel C, then we can say these three vectors are together coplanar or collinear. So that's a very important type of vector we'll be learning in these classes. So these are all the basic vectors there is, and there is um, another type of special vector, which is the parallel vector multiplication. So when we multiply parallel vectors, let's say here vector A and vector B, if they are both parallel, so they are parallel, A vector is parallel to B vector. So if you multiply A vector to B vector, we will always get the null vector or the zero vector. So null vector is a vector that the magnitude is 0 and the direction is also 0. We can also say that it's a point vector because it has no direction, no points, no initial. The end point and the initial points are all equal or at the same thing, so they are called the they are called the null vectors. So these are all the vectors there is to know, and in the next classes we'll know about the addition of vectors using general laws of triangle, laws of polygon, parallelogram, and laws of components. So stay tuned.